Corbin, Mayne.
Hello.
What are we doing here today? Why are we here?
Well, we are here to talk about something that's very, very close to my heart, uh, and I think it's quite a contentious subject because it's something that I think some people avoid like the plague, and other
Hmm.
people swear by it. And it's just one of those really kind of boogeymen of the industry, which is coding and sort
Mm.
of more technical stuff. I think you can't really avoid it to 100%. So, of course, any Houdini artist is doing a certain amount of coding. But I do think that once you get used to Houdini, you get used to or get comfortable with a certain amount of it. And you
Hmm.
potentially stop pushing yourself and figuring out what else you can do with it. Because there's so many toys, shiny toys in Houdini to focus on that you could spend a lifetime mastering, that you don't have to become very proficient in other coding languages or the slightly more technical side of Houdini, and you would still, be a master of many things. So I think it's something that people do tend to avoid,
Yeah.
but it can be incredibly powerful. And I think one of the things that I've been trying to push for many, many years is that there is a middle point. You don't have to become a pipeline TD, but I think the base level that people do learn is not enough, because I think there's so many useful things that you can do if you just go just a step or two higher. And that's
Yeah.
what I'm hoping to do with this new workshop is essentially guide people from the kind of comfort zone that they are in Houdini, into a little bit more like, hey, what can you really do with VEX? But like really as a language, like what crazy things can you do with VEX, and also how can we bring Python into the whole thing and let that help us? And there's so many situations where there's only one way to do it, and that is with Python. And so yeah.
I I agree. I have that limitation. I only know Vex. I know I can read a bit of Python, but I'm not proficient enough to actually use it, like to build proper
Mm.
tools. And I'm just now building a new noise tool for Pyro, and it's all Vex based. But if I knew just a bit of Python, I feel like I could actually make it into like a proper tool. Um, so yeah, definitely I need to dive into the workshop and actually
Yeah.
learn Python. Yeah.
And learning it, knowing, it's funny how learning Python, even then when you're not writing Python, it's like Python will enhance the way you think about your VEX, or it will
Yeah.
also help you lay out your scene better, because it's all just data, like nodes. Putting nodes down and building an advanced setup is the same as writing a big chunk of code. It doesn't,
Yeah.
it really is
It's
using the
the
same
logic.
logic. And so the
Yeah.
more of them you learn, then it kind of informs all the others. It's like you can tell someone who knows, three or four languages, like actual, you know,
Yeah.
like
I
English
do.
and
Yeah.
whatever,
Yeah.
can learn a fifth one and a sixth one and a seventh one really, really easily. And they start to even intuitively understand things about languages because they know several. But someone who knows only one
Yeah.
struggles
Is
to learn the second language. It's you've got to break through that barrier. And so I think
yeah,
it's
it's a
just
muscle.
so useful. And I'll be very honest. I'm not a master of Python or even
Mm.
a master of VEX. I still think every day there's things that I'm uncovering that I didn't know before.
Hmm.
But I do know a lot more than the average person, and I have found that that has helped my career massively. I mean, I also think that if you want to be a lead or a supervisor, it's not mandatory. They don't ever say it in the job description that in order to be a super, you need to know code. But
But it helps a
having
lot.
been a supervisor for many years and having learned code, I don't know how I would do it without that, because a lot of your job as a supervisor is like solving problems. Your team gets stuck. Even your really senior artist on the team gets stuck with something where it's just breaking. They send it to the farm and it breaks, and now they don't know. And sure, you usually have a technical team at a studio, but also sometimes they're so busy, they're like, oh, we'll get to that ticket at the end of the week. And you're like, no, we need to move now. And your ability to be able to sort of solve problems
Yeah.
is is really part of the job of being a supervisor. And so having at least a sort of a notch or two extra of technical skill, I think puts you into the running to be a better supervisor. So yeah, I just think it's just something that everyone should learn at least a little more than they currently do.
100%. Yeah. So like I was just I'm building two tools. One is the suit tool and one is the noise tool. And they're literally all VEX. And I wouldn't be able to build that if I didn't know how to code in VEX. I tried using AI a bit on the side and it was breaking everything. So I think I spent like a whole day arguing with AI. And I was like, okay, I'll try this just to see. And I'm using I tried 5 different AIs.
Mm-hmm.
And I was like, I'll try it. And I'm telling you, if I didn't know how to already code, it would be so useless.
Yeah.
It was actually confusing me. It was actually giving me wrong data. And it was giving me syntaxes that don't exist. And if I didn't know that it doesn't exist and that he's actually lying to me, I wouldn't be able to. It would be even more worthless.
That's exactly the thing. You have to actually already be an expert at coding to be able to figure out what it's gotten right and what it's gotten wrong, and it's crazy. So I would not. I mean, the AI is. You sent me something that you were like, hey, is there something wrong here? Can you spot it? And I was like, who wrote this?
Yeah, because you were like, is this? Yeah, it didn't make any sense.
It doesn't. The thing is, it doesn't understand. So, like the context, it was trying to store data that would be persistent, frame after frame, but it was giving it to you in a wrangle that was just at SOP level. It wasn't inside of a solver.
It didn't know.
It was just wrong.
Yeah, but it was telling me that it works. It was like, no, I'm storing it. I'm like, no, you're not.
No, you're not.
You're not. And he was like, 100%, this works.
Yeah.
And I was like, okay, yes, but I need to put it in a solver. And if I didn't know that, if I didn't have that knowledge beforehand, it would be useless.
Yeah.
And even then I had to rewrite. It was like a whole thing. Yeah. But so what are we even talking about today? It's your new workshop, Mastering the Art of VEX and Python.
Mastering the Art of VEX and Python.
Yeah.
And really what this course is, I'd sort of designed it from the end goal backwards, right? It was designed to be a practical workshop because I love building tools. At Double Jump, we've got loads of ideas. I mean, Urban and I literally sit on calls half the time discussing ideas and, oh, this would be cool, and, oh, can you do this? Or like whenever you call me up, I know you're going to ask me for some crazy idea like, oh, how could we do this? Or how could we do that? So we've got this giant list of dev ideas and tools that I want to work on and tools that I've been working on even before we started Double Jump. I've like had ideas before in dev and so I wanted to funnel that into just building a library of amazing tools, really, really functional, incredibly cool tools, right? But then I was like, but you put in so much effort into building these tools, so much actual knowledge of Houdini itself goes into building the tool, but then it's all packaged up and people just use it and they just get the end product. And it's like, do you know what we should do is we should use the tools as really good examples of how to build code in Houdini. The setups inside the tools are amazing, and even the packaging, the scripts that run when you drop it down or when you plug something in, and all the logic behind like when parameters should be disabled or hidden or whatever, and even just the user interface, like almost UX design of like how should you label your parameters and what order should you put them in, and all that type of stuff I think is really, really vital to learn from actually functioning tools. So the idea was basically, let's take our Double Jump library, every single tool we build, once it's developed enough that it's maybe we've ironed out some of the bugs, we put that into a tutorial.
Yeah.
And it's the opposite of black box. We're completely opening it up and even having a tutorial to explain every single thing that I did to build that tool.
Yeah.
And that would form the basis of this workshop. But then obviously if you're coming in and you don't already know all the coding, then you're making a big leap into suddenly doing like crazy stuff. So we've also built two modules that lead into it, essentially a VEX primer and a Python primer. And what I mean by the primer is it's basically a crash course, or it's like a cheat sheet for people who already maybe know it, but maybe don't use it on a daily basis. Because you know what it's like. You learn something, but then you do a project. Like I forget like how to use Pyro all the time because I'll work on a big water simulation project for like half a year, and then I haven't touched Pyro in ages. And then you're like, how do I do this again? So it's similar to that. I was like, right, even if you need just a refresher, you just do the primer. The primers start very basic, as though you've never touched it, but they ramp up quick to the point where. So if you start to it'll be easy, and then you'll hit a point where it's difficult. You just need to repeat the lessons until it gets you there, because it's designed to get you from wherever you are to the level you need to be able to do the rest of the workshop.
Yeah.
Then it's just practical. We're just actually building tools. And we've started with building the tools that we actually did for the explosion workshop. So the master exploder tools, the Scadoosh, just all of that.
Yeah.
But the idea behind this is that this is a perpetual workshop. It's a never-ending, open-ended workshop. So phase 1 is VEX primer, Python primer, and all of the master exploder tools.
Yeah.
But every time I finish a tool and polish it enough, I'm going to release it. And in fact, we haven't kind of worked out all the details yet, but what I'll probably do is all the people within the kind of legendary or supremium like groups on the TD workshop will be part of essentially just perpetually part of the alpha and beta testers. So even when I've got early parts of the tool where it's not ready for a tutorial yet, I'll still be sharing the tools and letting you guys actually help me kind of like come up with ideas, or, oh, could you add this feature because this would be cool. You can even give me ideas if you guys are like trying to build a tool and you're not sure how to do it. I might take that idea and run with it, build a crazy tool and actually make it work.
Yeah.
And then once it's working, I will build a tutorial showing every step of how to build that tool and add it to the workshop. So the workshop is always going to be growing and essentially is our open-ended library of tools for double jump.
Love it. Yeah, I still want a slow motion volume retiming tool. I know you were working on something, and it was, in theory, it was very close. I was like, that is the way to do it. But yeah, it's
I haven't.
Close.
So that is a tool Urban and I were discussing like ages ago, and it's pretty cool. We've been playing with it, and it's really nice, but it does need a little bit more work. So when I get time, eventually, I'm going to finish that tool, and that we should be able to do crazy things with it. Retiming, volume upraising. I know there are already setups for that, but I think this one will do probably a better job. And it does things like creating age fields in volumes, and you can do even more advanced color mixing because you can have things actually mix and then re-separate. And there's just so many things you can do with this tool because it's essentially turning Pyro into Flip in a way, where it's Pyro, but then it's got companion particles that are advected, and then they store values, and then they pass those values back to the fields, and so it's just this crazy, like it enables you to do so many things, and so I'm really excited to finish deving that, and as soon as that is dev, believe me, that this workshop is where that is going to go, and it's probably going to be like 50 hours just to explain how I built all of that.
Yeah, so I think so. Yeah, I've seen it in action. It's very interesting and 100% the right way to go about it. Yeah. Cool, man. Like, do you want to maybe share your screen a bit and like maybe show us some cool things? Or I've seen the workshop. There's like 100. I think Eva was saying more than 100 videos. Yeah, it was like more than 100.
Yeah, it's a lot. I think it's like 150 or something, or whatever. 100.
Yeah, because she was putting each. She was going, but. She was putting all the videos in, and she was like, "Do you know how many videos Corbin recorded?" I was like, "I have no idea." She's like, "I think she said like 125, where it's like or close to 150."
Oh wait, no, here it's I've got 102 in this list, but I mean it's gonna get even more. You'll see.
Yeah,
and I mean if you know me, I like to rant and talk, and so they're not 102 10-minute videos. They're probably about an hour each.
Yeah, I think the workshop is probably Do you know how long it is?
Um, it is.
I think
I don't
53
actually know.
hours. Yeah, it says here 53, which is a
53. Yeah.
lot. Yeah, but
So it's a lot.
yeah.
And it's going to get more. That's the whole point, is that it's going to keep getting bigger and bigger. So,
Hmm.
and I would say this is an interesting workshop. Of course, you could do it beginning to end, but you also don't have to. You can kind of
Yeah.
graze on it. You can nitpick. If you really feel like you already know your VEX really well, you can skip that section, but then you do the tools. But even the tools, you don't have to do them in order. You can do whichever ones
Yeah.
interest you, and yeah, so
Hmm.
I think
Yeah.
there's just a lot of information in there.
Yeah, I like it.
And
Yeah.
the one thing I wanted to show actually with this is why I've started with this scene.
Mm.
This is actually my Obscurus scene from Film Effects,
Hmm.
which I'm busy finishing up the rendering now. I've just got some weird segmentation faults that I need to fix, and then we should be
Mm.
ready to finalize the renders, which is cool. But I wanted to bring this up because, of course, if you learn coding, you can build crazy tools. And that's one really obvious thing to do with it. But I do often say to people, you should know as basic Python, just because it helps you do things inside of Houdini. Anything repetitive you're doing, it can make your life a lot easier. And so I talk a lot about these ad hoc scripts. Something that you're not even necessarily going to turn into a shelf tool or an HDA or whatever, but you're busy working in your scene, and now you've got like 20 different nodes that you need to change a value on, but then maybe later you're going to tweak the value and then you need to copy it 20 times, but you don't want them like relative linked because of certain reasons, or you want to like go and push a bunch of buttons, and how can you do that? Well, you can do it with Python. So often, probably once a week at least, I am writing some little ad hoc script at work to just do something, And so I wanted to show an example of this because often it's hard to even think of what you used it for because it's just so pedestrian, but it's so useful because it saves you hours.
Mm.
So in this scene, I built my city using Kitbash, okay?
Hmm.
And essentially the way it imports it, it brings in all the assets but they were referencing their own variables. So it's a $kitbash assets, I think, is the variable. And there's actually a bit of a bug with the Kitbash app where you can choose a location for it to download to, and that was then the location that I was also backing up. So I was like, oh, this is going to work well. But actually, when you download it, some of the assets go there, but like I think the materials go in another folder, and you can't actually specify where that folder goes, and it's such a pain. So I was like, right, what I'm going to do is just copy everything from that folder where I don't want it to be into my folder. But now the variable is pointing in the wrong location. So this was the issue. So I just wanted to reroute it all by changing every single one of these references $kitbash assets.
Hmm.
And I also, all the materials, and this was a crazy one, inside all the materials, obviously every single one of them has got a bunch of textures that all reference it as well. So we're talking about hundreds and hundreds of references with this variable, and I wanted to go and fix that. So just literally built a little ad hoc script that runs through the entire scene, everything inside of here that references an external file and swaps the kitbash assets reference with $assets. And then obviously I'm using my tool, which is another tool that we will be covering very soon in the workshop. The reason it's not covered yet is because I'm actually in the process of massively improving it and reworking it, and then I will be adding this. This will be the first tool added to the workshop. Where in this, it's basically all about setting variables. So now I can go and set an assets variable, point to exactly where I want it to be, and as long as I could replace every reference of kitbash assets with a $assets, then everything works. And so just on top of the tool, I just built this script and a little button, and I can click it and it runs. And you'll see here it actually prints out, because I did add a new shader in there, that it has actually repathed 5 assets. So I dropped in a new shader, and it was referencing all these different textures on file, and instead it's now rerouted them. So if I go and look in at that new asset, this new one that I dropped in, you'll see here all the textures now have $assets instead of $kitbash assets.
Yeah, I would probably do this by hand, and it would take me 2 days.
Yeah, but now and it's repeatable as well, because now I kept adding to the city. I was like, oh, from this angle, it looks a bit blank there, so let me add a building or two, or the road doesn't look right. I'm going to import a new asset with a different texture. And then I keep having to do it. I was like, I don't want to do it. So I made this thing. Now you click a button and it works.
Yeah, I love it.
Hours of my life that this has saved me. And look at that. It is, what is that? 24 lines of code. Okay? This is not hard. If you sit and read it, you probably can see exactly what it's doing, because Python's almost English in a way. It's like it's so readable. Now, in addition to that, there's something else I did in this scene, which was, that's why I also brought in this material. You'll see all of these are Material X shaders. Now, the kitbash does technically come with, you can import Material X materials, but we actually found that they are not set up correctly. They're not like pathed correctly. The roughness is going into diffuse roughness instead of specular roughness, and there's just this problems with the way they've written it or whatever. I think that they must have some kind of code on their side as well, so it just wasn't working for us. Also, the thing is, it drops down a subnet which doesn't have the correct Material X context set, so there's some compiler stuff on it. So so if you drop down a Material X shader, like builder, you'll see it's got this whole thing here. And what that means is when you dive inside the subnet and you start hit tab, what you're looking at is Material X nodes. Whereas inside just a standard subnet, even though this is a subnet, you can see there, it's a subnet. But inside of this over here, you start, and it's now giving you access to nodes that are not going to work with Material X.
Yeah.
Okay. So there were some issues basically, and so we fixed this by creating a script. Now this is something that I'm actually going to include with the workshop, as well as with Film Effects, because obviously it's part of Film Effects. But yeah, there's this. It's quite an intense chunk of code, and it definitely needs work. It needs more added to it. But what it essentially does is converts. So you click that, and it gives you a new shader. It's got everything set up correctly, so it's a Material X shader, and you'll see here it completely rebuilds everything. So over here, what was all of these? Like, they've got a toggle, they've got a thing, they've got a multiplier. That for all of these different things, base color, roughness, whatever. But the thing is, base color is not just overriding with the color; it's multiplying by the albedo, right? Well, so the base color over here. So our shader does exactly that. It takes whatever value was plugged into color and instead creates a constant for that, and then gives you the texture, and then multiplies it and gives you the switcher as well. So it rebuilds everything, as well as correctly rebuilding the displacement as well. So not only that, but also multiplies it by the correct amount. It plugs in your normal map. Yeah. So literally one click, and you can do it with, I created all of these literally in one click, because it was all just a bunch of VEX materials with principled shaders. I just selected them all, clicked the button once, and it just creates one for each.
Wow.
So this is examples of stuff that you can do with very basic Python knowledge.
Yeah. No, I need to jump on the Python train. I've been saying it for years. It just, I always needed a good excuse to do it. And each time I hit a bottleneck, I'm like, I could probably solve this with Python.
Totally. Well, let me actually say the difference between VEX and Python. VEX is essentially building a custom node. Nodes in Houdini at SOP level or other contexts are just doing a particular thing. They are a chunk of code. It's like they're a block of code. They do one particular function. With some variables, parameters in this case. But when you drop down a wrangle, it's kind of just an open-ended, you're just filling in what it should do. You're creating your own custom result or function out of that, and then promoting the parameters. So you're creating a custom node. Python breaks completely out of Houdini. Like it's not within a node. It doesn't live within a node. Anything that you, the user, can do, Python can do. So this is a really good example, this repathing. If you said you'd have to do it manually. Anything where you would do it manually, going in, clicking a node, and changing a value, if you can do it manually, Python can do it. And the amazing thing about Python is that it doesn't have to stay within Houdini. So it can create a folder on your desktop, and it can send you an email, or it can, you know what I mean? It can do other things. So even if you had to like render a bunch of files, and then when they're finished rendering, then you want to take them all and create a MOV out of them, and then put that MOV through, Handbrake to compress it or something like that. Python can do all of those steps. It can wait for things to finish and then do this, So anything you can do, if you're getting bored, you should instead be using Python.
Just build a script.
Yeah. So anyway, I just wanted to show that, because that's like a lot of the time people ask me like, well, why should I use it? Like, I'm not that into building tools. I'm like, no. It's well beyond what you can do in tools. But talking about tools, the thing is, a tool doesn't have to be boring stuff as well. It doesn't have to be pipeline tools. It can be, what it is essentially is, it's taking your setups that you've worked so hard to create and just wrapping them in something that is user-friendly, so that, other people can easily use it, or you in future when you forget the setup. You have a nice user interface that helps you use the tool. So that's what I want to show you next, is our MX tools, and I'll show you the Scadoosh stuff. This is some of the tools that we've developed the most. So obviously these at its heart were based on Urban's setups. So this is hard work that's been put into techniques for how to create great explosions. But when they're just living in HIP files, or a bunch of theory in your head, or techniques that you always do this or that, there's all these little tricks, then it's really hard to package that up and share that with other people, unless they're willing to. First of all, you would have to be willing to sit and make a giant tutorial of all of your steps that you do to create an explosion, which obviously you have done, ultimate explosions. But then people would have to also watch all of that and absorb all of that and remember it and then apply it every time. And so actually packaging all your hard work into a user-friendly tool is such a powerful way to just carry your work forward. So even if you're not going to build like crazy pipeline tools, just think of it as like, creatively you build really amazing effects and then turn it into a tool. And so what we've done is obviously built our own explosion setup. And one of the main things we wanted to do was to be able to make, really control the shape of the explosion ahead of time. So this, especially the direction bias here is my favorite part of this tool. The fact that it just literally points everything, like reorients everything in that direction, and you can control how strong that bias is. So you can influence some scale or the angle, and let me think what else. I mean, we've got collisions, and just how you can control the shape. You're adding extra like random spikes and reseed those spikes, or tell those spikes to ignore. Like you can create custom spikes, but then have those spikes affected by the direction bias or not. I mean, there's a lot of work that's gone into helping you create the exact shape you want out of this explosion. But all of that is literally, it's a really awesome setup, and then it's a hell of a lot of coding and even just logical thinking around how to create it into an HDA that is user-friendly, So things like, down to the smallest thing, how to put a custom like logo on your thing, how to label your inputs and make them different colors, and thinking logically about the flow of your parameters so it makes sense. So if you should not have to explain to the user how to use your tool. If you give it to them and you've done it right, they should be able to figure it out.
Yeah.
And that's a really cool way of testing your tools. Build it, give it to someone, say nothing, and watch how they play with it.
Yeah.
And what they click first and what they do with it. And it's really interesting. But yeah. So these are the tools we go really, really in depth into how to build. Now, these tools don't particularly involve a lot of Python, but they involve a lot of VEX and then HDA work. So there's a little bit of Python. In fact, let's see. Are there? I can't even remember if there's any scripts. So there's no scripts on this one even at all. I think source attributes has a few scripts. Yeah. So there's a couple of very basic scripts on here, but there's not a lot of Python going on. But it is a lot of parameter work, things being hidden or not, or creating wrappers in the folders and stuff so that we can hide things or disable when. Also, all your tags, so you can actually control how things collapse or not. So, in fact, let me try to remember on here. In fact, this is a slightly older version of this tool, I think. But if I drop down the new version, which in fact you guys are getting a first preview here of the new changes I've made to the source shape tool. You'll like even the fact that like here you've got something that collapses or not, but the toggle is actually sitting as a header for this. Like all of that is stuff that a lot of people don't know how to do with their HDAs. But when you build it in the right way, it can be really intuitive. Like how to use your tool then. So that's the type of stuff we're going to show you how to do. I'm literally going to show you not just the HDA stuff. We're going to go inside every single node in here. I'm showing you the code, like what's going on in there, how to build it, how to link it all, the visualizers, all of that. Okay.
Yeah.
In addition to that, of course, we have our Scadoosh Pyro helpers. Which is basically a wrapper for a whole bunch of other tools. So the mask field, the gas disturb, gas turbulence. We've built a whole suite of tools. Some of them are things that don't exist. So gas accelerate and gas drag do not exist. So these are just double jump tools. But then there's others like a gas turbulence, which of course there is already a Houdini gas turbulence, but we have essentially improved upon the original. Because every time we used it, we found there's limitations. We're frustrated about the lack of an additional feature, and obviously waiting for side effects to add that feature, it obviously depends on whether they've got someone working on it, how seriously they would take your feedback. So we were just like, we'll just build our own.
Yeah, and that's what people do in studios. Like every studio has their own suite of tools, and then honestly, a lot of times side effects would go and visit all of these studios and kind of get feedback and see, okay, so you guys are doing this. So maybe that is something we eventually need to put in, but the studios will have custom tools. And that's essentially how we're thinking about this. Like, it's like, what do we need? And then we build a tool around it.
Yes.
And you can do it if you know how to use VEX and Python.
Exactly. Yeah, you can basically make it your own. In fact, it's one of my favorite things to do. Obviously, I love building a tool that no one's ever seen at all. It's great to just present some tool where people are like, oh man, where is that node in Houdini? And you're like, no, it's nowhere. It's my node.
Yeah.
But actually, my favorite thing is just wrapping up, just packaging up a tool that already exists, but just adding extra things. Because then it's like in your scene, when you do gas turbulence, you've got extra features that no one else has, Yeah. It's like, it's so nice to, instead of being limited by someone else's tool, you say, oh, I'll just make that better and just package it up.
We're just adding spoilers and neon lights and freaking better exhaust system.
Yeah, exactly. Freaking it out, man. And it's just, all the features you want, you just add in.
Yeah. So what did you add? Because it was something that's really useful.
Oh yeah. So gas turbulence particularly, there's got a few things. One of the main things, but that's actually something that almost all this whole suite of tools has, is the control settings, the control fields. And this was actually a request from Urban, which was, if you do the normal gas turbulence, you've got a control field, but it's only
It's
one control field.
Only one. It's
Yeah.
insane.
So sure, you want to mask by temperature, that's fine. But now if you want to mask by temperature multiplied by some other value, but then clamped to this or whatever, you can't do that. Or you have to create a custom field that you then feed in as one field.
Yeah.
That's quite expensive. So we were like, well, let's just make it that you can add more. So I'll just drop down a clean one. So here you can add several control fields. Okay.
99.
We're actually
99, I think.
Yeah,
or 100.
10.
Oh, is it? No, wasn't it 99?
No, I limited it to 10 because actually I explain in the workshop why we can't do it infinite, like just let it add as many as you want. And I figured that 10 was more than you would ever use.
Oh, no, 100%. Yeah.
If we get feedback that people need more, I'm happy to add more. It just requires a bit of manual work to add it, because you'll see if you dive inside, you'll see here you actually have to manually build all 10. And I explain why. But actually, this is where I've used Python in this tool, even in a hidden way, is that once I knew what needed to be changed in each version, I could now copy it as many times as I want and then select them all and run the Python script that I built that then goes and reroutes all those values. So we could make as many as we want.
Yeah.
Anyway, so it's got multiple control fields. The other thing is that the naming convention, I personally hate the naming convention of gas turbulence. Because, for example, why is it called grain? When on every other noise function, it's called roughness.
Yeah.
And the thing is, if you dive inside of the gas turbulence and look at what it's doing, it is literally just feeding in the grain value into the turbulence of a curl noise. So it is not even doing anything. It's not like grain is the inverse of roughness or whatever. It is just a different name for it. Why?
Yeah.
So, but I didn't want to force my views on other people. So I put in a toggle here for the different parameter style, and it's got all the same values, but they just are differently named. And I prefer the curl noise style, so it's named exactly the way that curl noise is. Also, things like your frequency and amplitude can be a single value, but also have the 3 components as well, exactly like some of the new noise functions are working like on SOP level. So we added all of that in. We added pulse, so you've got essentially offset over time. And then we also built in all of your pre-processing, post-processing, and then also how this is actually applied. Because if you just stick down the gas turbulence, it is just additive.
Yeah.
That's your only option. It's additive, right? But here we are like, well, you can just replace, or you can add, or you can add with a clamp to a maximum speed, or you can multiply your values, or you could do a pull function. So it's got the how to add this into your other forces built into the tool. So there's a lot of cool features built into that, and I'm going to show you all of it. Every step, the logic behind it, how to build it, all of it.
Yeah.
And then the same with all of them. I mean, gas turbulence. Okay, this is a new one as well. Gas mask field. This is crazy. This one is awesome. It's got so many cool features for how to create masks. So you can mask by speed, and it's got all sorts of controls for that. You can mask by gradient direction, so it does the dot product function. In fact, you can mask by both, and then so combine the two, and then it comes up with a mask field, which then can be fed in directly into these. So you could create a field here like a mask, and then in your turbulence you could just mask by your mask field. Yeah. Oh, and in fact it's also got some special ones. You can mask by P, Y, or PX, which is not normally built in as a feature, but we added it in as an additional mask, like intrinsic masks that are always there. So many features that we've built into this, and the wrapper is really nice because it just lets you kind of access all of them in one nice tool. But you have to. You could drop them all down individually, or you could have multiple Scadoosh wrappers and just plug them all in and do different things.
Yeah.
And
in fact, my favorite one is the wind. I think the wind is super natural, and the way really it works is exactly how wind should work.
Yeah. The problem with the current wind, well, besides the fact that the wind force, gas wind, and pop wind all work differently and have like completely different names for the settings, and it's like so stupid. Why? So we've unified it, and in fact, look, so this is a gas wind, but I am also going to be creating, in fact, you'll see I do have a geometry wind, but I haven't finished developing it because I want it to look exactly the same and have all the exact same features. And because then you can feed the same settings in, and you'll have particles move the same way that fields are moving. But the really powerful thing with this wind is that it has a pulse slide. So essentially, it's like waves of wind moving. Instead of it just being turbulent and then with an additive vector for the direction. So it's essentially it's moving in that direction, but also plus some turbulence. Instead, I wanted it to be that the turbulent noise shape was offset in the direction and by the same speed as the wind direction. So your noise patterns are being advected by the wind, not just simply added on top and it's sliding through, so that you get that sort of moving wave that happens. And the pulse slide set to 1 basically means that it advects 100%, so it moves exactly to the speed of the wind. But what's more realistic is actually slightly dropping it, so it sort of lags a little bit behind, and then you can also have a pulse frequency, so then it slightly changes and evolves as it moves. But you get this really nice sort of feeling of like moving waves of wind rather than just turbulence added on top.
Yeah.
So that's, really cool feature.
Yeah, there's a free tutorial that I recorded somewhere on our website, or if you go on YouTube and just type Scadoosh, you're going to be able to see I did a demo of all the Scadoosh tools, and gas wind is like by far my favorite.
Nice. And more features coming for the gas wind, because the fact that we're going to do geometry wind with the exact same parameter styles and settings, what I want to do is actually build a global wind tool that you can link to a list of all of this. It'll like look through your whole scene for any wind tools from like double jump wind tools, and you can basically link them. So then what you could do is in one place you could create the wind in your scene. And no matter where you have a gas wind or a pop wind or whatever, it'll all just have the same settings,
Yeah.
Or at least that would be your base, and then of course you could add extra on top of it or multiply it or whatever. So it just feels like everything moves together in a unified way. It's pretty cool.
Yeah.
So and then you'll see even these there's so many tiers of, because inside of Scadoosh is all the suite of tools, but inside of all these tools are actually more tools that we've built, which are our apply force tools. So there's a whole suite of them: apply force, add, multiply, maximum, minimum, blend, and then my favorite, which is pull. And these are all really powerful tools on their own, and if ever you want to use them, so they all exist at VOP level. So if you do like a gas field VOP, you'd be able to drop down our apply force pull. And all of them are essentially doing the same thing. They're combining two vectors, but how they combine them, it gives you a lot of control over how it works. How to merge the two. Do you want to do a pull function, and then do you want direction or not? It's also got one of the problems with pull, the only problem with pull really, is that areas where you've got a zero velocity, it just kills everything, unless you have deceleration set to 0. But sometimes you don't want that. So here we've got a minimum cutoff threshold, so it kills any low values and only treats from that threshold higher as a value to consider. So we've essentially fixed the problem with pull and then included it as a nice convenient node. And the trick with this is that it's at VOP level, which means that, because VOP is, even though there's gas field VOPs, SOP VOPs, like there's lots of different VOP contexts, they all share the same sort of subcontext. So if you drop this node down here in a gas field VOP, you can also go up to SOP level and drop down a detail VOP and drop it down here as well, which is so nice because then you can actually link them. I've done it before in film effects where in the Disintegration, where we built a visualizer at SOP level and then linked all my sims to the one wind node at SOP level, because they all live essentially inside of VOPs, which is a shared context. So that's the really cool thing about it.
Oh, by the way, just recently we finally finished the render for Disintegration. Do you wanna show it here, because it's really cool?
Yes, if I can find it. What I'll do is I'll pull it over to the side, just go searching.
And then Obscurus is next, and then Bubble Bomb. I know you're going to be doing that soon as well.
Yeah, so Obscurus I'm busy rendering. Like I say, probably would have even been finished now, but we had a few segmentation faults on random frames, so I need to investigate, and then we'll be done. And then Bubble Bomb, I'm doing some nice big changes to it, but that's already underway as well, so that's going to be very, very soon. I've already got the ground set up and everything, so I just need to basically rerun my sims and then do the lighting. Okay, Disintegration. Here we go. So I'll pull that over. Talking about the wind, the fact that, so there's all these little particles, there's some very soft volumes moving through, like just to show that the wind is moving, but all of the vellum sims, the extra particles peeling away, everything is affected by wind forces, double jump wind forces, that are all linked to one control that is at SOP level, so that I could essentially visualize it at SOP level and then feed it into all of the DOPs. And it made it so easy, because then when I was tweaking the wind, I could just go and get it right on a little test. And then once I knew the wind was moving right, I would just rerun all the sims, and of course they would work because they're all linked.
Nice. So, yeah. This is, the quality is, it almost looks like a Love, That and Robots episode. Yeah. Very cool.
I mean, obviously, there's always things you think, oh man, I'd like to improve that or whatever. But yeah, I think it's, in terms of a disintegration effect, it applies all of the techniques that we learned over doing so many disintegration effects. I mean, we did a couple at Axis together, you and I. And then when I was working on Sandman, I think in that one season, we disintegrated like 5 different characters in completely different ways. It was funny, like people turning into sand, people turning into ghosts, people like just evaporating. It's just crazy. So, yeah. Cool.
Sweet. Nice.
Anyway, so we do go very much in depth into everything to do with this whole suite of tools: Master Exploder, Scadoosh, the gas tools, the forced VOP tools underneath it. Every single part of it, I show you how to rebuild. And that is the level to which we are going to go with all of our other tools. And to let you know some of the tools that are probably coming the soonest, I mean, like I said, we've got a list, crazy list, but the soonest is we're going to give the next one I'm going to do is a pipeline tool for you guys. So that is my scene controls tool, which I always use to set variables and stuff. But like I say, I'm totally redesigning this. I was speaking to, I won't say names, but I'm speaking to people that I know that are pipeline TDs and getting ideas and stuff for how we could build. The idea is I really want to build a very freelancer friendly pipeline tool. So no matter who you are, you don't have to build your own. You can just use this, and it should be able to be plugged into almost any, like however your client wants to work and whatever their folder structure is, this should be able to be adapted, because all you want to do is on the node, you just build the folder structure, and then it does all the work for you to then figure out variables and how to write things to it. And so that'll be a much more Python heavy tool. That's coming probably the soonest after all of this. as well as a big wave of changes to the master explorer tools and stuff that we're working on.
Yeah.
And then, the advection tool that we were speaking about, which allows you to do volume retiming, volume upresing, or just quick advection if you just want, like, oh, I've simulated some, like an explosion, but I want particles moving in there. It's going to have like quick presets for that as well. So obviously that's fairly easy to do, but the fact is you can now drop down one node and just say, hey, I just want debris, and it'll just do it for you. And it's just really quick and easy. So it's got like so many different options and functions, but really at its heart, it's a sort of a reseeding and inheritance kind of advection system, very similar to Flip, but just designed for Pyro. Or essentially, here's another way I sort of, in my head, I like to think of this tool. What if you wanted to drive Pyro using particle nodes? Like you want to use a pop wind on a Pyro. Well, this tool actually lets you do it, because you can actually drive the particles by forces and then can transfer those forces to the Pyro. And so it essentially bridges the gap between pops and Pyro, so they can speak together in the same way that in Flip you can use pop tools, but you can also use volume tools. Well, Pyro will now have the same features.
Yeah,
that's my pitch.
Nice.
For that tool.
I like it. Yeah,
so that's very useful as well. I've got a tool that I'm working on for. Well, I essentially want to redesign the file cache node, but to do some crazy things like, obviously working with our pipeline tool and correctly storing your data, but also things like, it really bothers me that you have to try and figure out your simulation frames, like your frame range, particularly if you run, like, let's say a burst, like an explosion. Once you've run out of explosion, like once there's no more voxel data, you'd want it to just stop caching, but maybe you're doing it very procedurally, you're scattering a whole bunch of explosions. You don't know how quickly it's going to fade off. So what do you put as an end frame? And if you put it slightly too short, you have to resim the whole thing, because that's how simulations work. You can't just keep carrying on unless you store your sim frames, like your sim data, right?
Checkpoints.
So you always overdo it and cache the whole frame range, but then depending on your network, any parts that are time dependent, it has to recook. So even though it's not cooking voxel data in the solver, it's wasting a lot of time. So I'm building something that actually can sort of switch and, like, based on certain thresholds, can then actually just cache a null for the remaining frame range. So then it allows you to cache all the frames.
Yeah.
But it goes really, really fast. So things like that. Just some cool tools coming down.
Yeah, very useful tools that you can find in many studios, but they're obviously not accessible to the public. You have to work at Veta or ILM. Yeah. And now hopefully through Double Jump we can maybe release some of these tools that are going to be useful for freelancers or like indie studios, or if you're just learning, you can now learn how to do them on your own as well, which is
exactly
even more useful. But yeah.
And that's the thing that I want people to take away from this whole workshop, is just having that ability to not be limited by the software, but you design the software, really. You design the tool that you want. So if you're limited by any features in Houdini, you just say, right, well, I'll just build my own, and you just fix it for yourself. And that can work really well for freelancers, but it's also, you can take that knowledge to studio work as well, and saves you a lot of time.
Yeah, 100%. And people who can do that are usually the most useful, and not just useful people in the studio, but other people start depending on you, and then you become, what's the word? Irreplaceable. Well,
this knowledge has actually saved my job multiple times, but one time very definitively. I was actually still very, very basic knowledge of Python at that stage. A guy at work was helping teach me, and I was doing a course on the side, like I was sort of like doing extra study after hours. But I could do very, very basic stuff by that stage. But just the fact that I was an effects artist that also knew that. I was at a small studio, maybe 60 to 70 people, but we lost So we would only really have like one project at a time, or maybe there'd be a little bit of overlap between projects. And then we literally lost a project that we thought we would have, and we couldn't pick up another one quick enough. And so they actually said to everyone, listen, we have to just let everyone go.
Yeah. Except Corbin.
We'll get you back in.
Corbin, you stay.
Yeah, exactly. They literally kept, it was like 5 or 6 people.
Yeah.
Because they were like, look, this is an opportunity. We're going to probably be closed for a minimum of 3 months. It might even be 6 to 8. And our pipeline is so old. And it's always hard to change a pipeline while it's going. So they were like, right, guys, you've got several months, just redesign our pipeline. And I was like, literally, I just started learning Python probably maybe 6 months prior to that.
Yeah.
And it's the reason I kept a job. They were much more experienced artists than me, but I had the combination of effects like Houdini knowledge and Python knowledge. And they were like, cool, just stay. And in that time, obviously forced to sort of build a pipeline was what got me to level up my Python skills, because I was working with the guy who was teaching me. He obviously was one of the others that they kept, and he really knew a lot about Python. But I essentially was thrown in as like a junior pipeline developer, basically, as well as then when people started coming back, that's when I was able to then pick up and start becoming an effects supervisor, because I knew how everything worked. So that was not only did it save my job, it was my transition into being a supervisor.
Yeah.
So
there you go.
Cannot explain to you how much knowing Python and then also advanced VEX, like really not just the basics, not just a couple of little things, but actually really like loops and matrices and all the things that some people kind of get a little bit confused by. If you can master that, it sets you on another level, and that's where it helps you become a supervisor. It helps you keep your job. People come to you, then they know you at a studio because word gets around. They're like, oh, if you're stuck, just ask that guy. He's really good with that stuff.
All the departments. Yeah.
Half the time I'm building tools like at ILP. Like I'll build tools and little scripts and things to help the lighters.
Yeah.
Because of exactly that. Like they don't know it, and already as it is, generally lighters don't know as much about Houdini as effects artists, because effects really requires you to know everything. Like you really have to be quite technical just as a baseline. So they usually come to us already for anything beyond what they already know. But then if you're the technical effects guy, you have to start saying no. Like, listen, I don't have the time for this.
Yeah.
But then when they trying to decide who to keep, or offer a permanent position to or whatever, like who do you think they're coming to? It has helped me so many times in my career. I would not be where I am today if it weren't for Python and then advanced VEX knowledge.
Yeah, man, I like it. So hopefully people can take the workshop and get on that horse.
Yeah, exactly.
Yeah.
I did want to show one more thing as well, just quickly, which was kind of a cool little visual example of a tool, another tool that I have built. I'm already actually providing this one with the workshop, the tool itself, but I haven't done a tutorial for it yet. I will add a tutorial. That'll be it's a very short one because it's a very simple tool. But when I get the time, I'll add a tutorial as well. But you will get this tool with the workshop as it ships, which is essentially it bothered me that turbulent noise did not have a 4D noise option, like a 4D vector option. And so the problem that happens is what you can see on the left-hand side. If you want to offset the noise, you can see it sliding in a direction, unless you offset it so much that it's suddenly jumping to a whole different seed. So then you're just reseeding, but you can't have it sort of evolve, but in a way that you can't actually see the direction. And if you use it inside your sims, you can often see like diagonal lines somehow in the pattern, because you can tell the noise is sliding in that direction. Especially if you give your XYZ the same value, then it slides diagonally in the positive XYZ direction. So you get this problem on the left hand side, right? So I basically built a triplanar noise, right? It's essentially 3 different turbulent noises, but what they do is, so if you had only two, then what you'd have is in the middle. You're essentially blending from one noise to the other. But when the ball hits one, then so 0 is invisible. That's when you switch its seed, like you just offset it massively to a completely different area, and then you start blending back into it. So it's obviously blending into a different value. So it's ping-ponging between two changing values, but the change is hidden in the moment when you're all the way blended into 1 or all the way blended into 0, which is fine. But the problem is you then get this, you can actually see it, it switches and then it pauses, and it switches and it pauses. And sure, you can ramp that a little to kind of make it a little smoother, but you're never going to get it perfect. So the trick was to make this 3, so it's blending between 3 noises. Okay, and if you blend perfectly between the 3 noises, then you'll see here, instead of going back and forward, because if you're blending, as you're blending towards 1, you're also adding a little, as you're blending towards 0, you're also adding a little bit of 1. It essentially creates a circle. Okay, so it's circular noise. And at the moment, like here, where it's exactly 50% of noise 0, 50% of noise 1, and 0% of noise 2, that's the moment where noise 2 switches seed. And then it starts blending a little bit of noise 2 in. So you'll see as we go forward, it starts to blend more of noise 2 and less of noise 0, until eventually, when it's exactly opposite, that's when noise 0 switches seed, because it's invisible. But it makes a perfectly sort of evolving noise that's just smoothly evolving at a constant speed, but it never repeats. But what was also cool is that you could create a loop as well, because instead of offsetting to a different seed, you could just keep it the same seed, and so then you actually have looping noise as well, which was like a kind of a random byproduct. But looping noise can be really useful, because if you want something to be driven by noise and then a certain number of frames, and you want it to be loopable so that you can save time, like you want to make like glowing embers in the background and you want to put it on a card and it needs to loop for however many frames, you can just make a small little loop, and that gives you that for free as well. Really cool. So so we do have this double jump turbulent noise tool that I've built. In fact, actually, this is a slightly old version, but we do have it, a double jump turbulent noise. And you'll see this lets you, it's all exactly the same features of turbulent noise, but it lets you drive it with 4D instead of 3D, like a curl noise would. And then that just means that you have a time offset parameter for it. But you can also tick loop noise on, and then it will actually make it that it, when it cycles back around to 0 or 1 or whatever, like it'll be the same noise, so then it loops. Or if that's off, then it will constantly keep offsetting and changing.
Nice.
So,
yeah.
Just a small tool, but I really like this one, and I think you guys will find it quite useful, because it always bothered me when you want to like offset the noise and you're like, now it's sliding, and I don't know.
Yeah. 100%. Yeah. I feel like side effects should start implementing some of these tools.
Well, I was going to say earlier, we're going to definitely talk to them and try and convince them to adopt some of these tools. So hopefully that'll be in soon.
Yeah, hopefully. Cool, man. Well, I need to make dinner.
Nice. Nice.
This was very cool, super informative. I always get inspired looking at all of this, and I know it helped me as well. Like I said, I'm literally just finishing my tools, and it has like a ton of VEX, and the only reason is because, I spent a lot of time actually learning it. Like it took a few years, but once you get through that learning curve can sometimes be a bit painful. But I know you included in the workshop, the VEX primer and the Python primer, which are like very easy to digest. Like for VEX, like you almost, when you go through all the syntaxes, like, and show them on like simple examples. So once you get the hang of that, you can then start combining it and, taking pieces here and there and soon you're going to be able to make your own HDAs and tools and pipelines.
Yeah. I mean, even at first, if people just do the VEX primer on its own, it will take your effects work to a whole new level, because you will go from like maybe even using a bit of VOPs and a bit of Wrangle to basically everything you'll do is in a Wrangle, and it'll be so quick. You'll just type lines of code quick, and you'll move on. Like it'll get you to that level, even if you just do that on its own. That plus Python, you're going to be a much faster artist and much more efficient, and then add the tools to that, and it's going to absolutely elevate you to another level. So I guarantee you, because this is what I feel this was the heart of my career, was everything that I've poured into this workshop. So yeah, I really hope people learn a lot from it. I'm also very excited to keep adding to it. I'm actually itching to literally do another new module and new tools and new stuff all the time. So we'll get this one started and build the community around everyone who's joined can then start being my like beta testers, and I'll kind of like send out early versions of tools, get some feedback, and then you guys will see how this evolves and what new tools we add to this. But I'm essentially not planning on ever stopping adding to this workshop.
Awesome. Yeah, I think that's a good way to end this webinar.
Cool. Well, I'll see you guys all there then.
Yeah, thank you so much. See you guys on the inside.
Bye.
Bye.